Hello and welcome to another video. This is Cracking the Cryptic app Fog of War pack puzzle number 26, Pegasus. This is a really beautiful puzzle and I hope you guys will enjoy it. The rules are: Fog of War. Correctly placed digits clear the fog around them. Classic. Every row, column and box must have all numbers from 1 to 9 exactly once. And lastly, Partial Kropki. A white dot between two cells indicates that the neighboring digits are consecutive. A black dot between two cells indicates that one of the digits is twice as big as the other digit. Not all possible dots are given. Before we continue, I would like to take a moment and discuss something that I've mentioned in some of my previous videos, and that is symmetry. Now, I've used symmetry a few times, mostly as a guiding principle to help me see what I should look at next. And sometimes it's too hard to look for symmetry. Sometimes, especially like in cases exactly like this one, it is really easy to see it. Basically, imagine that these two cells are actually in a fog of war. So that we don't see that this is a white Kropki and we don't see that this is a black Kropki. We only see these four cells. Well, in such a case, this puzzle would be completely unsolvable. Why? Because you could rotate the puzzle and it would look exactly the same. So that means that you can't conclude for sure, for certain, any other digit, because, for example, if you could conclude that this is a 4, then this would be a 4 as well if you just rotate the puzzle and reason the same way. And then the same would be true for this and this. So that means that wherever the puzzle takes us, just this won't be enough to place our first digit. This and this is of absolute importance. And this guiding principle of symmetry is really powerful both in Sudokus and in general mathematics, right? So if we follow symmetry and we respect the symmetry, it usually will lead us in the right way. So let's begin. We have these three black Kropki cells up here, down here, and some over here. And we know that these cells cannot contain numbers 5, 7, or 9 because nothing doubles into these values and the double of their values is over 9. So this can only be 1, 2, 3, 4, 6, or an 8. Now you'll notice that these three are three black Kropki cells and that this is a central one. And we'll only reason about this one because all three of them share the same property that all three cells are in one box. So anything we conclude about this one is going to be translatable to these two. So let's assume that the central square is the number 1. Well, in that case, on one of its sides, you can have the number 2, right? But then nothing could be on the left side of the central square because you've used up the 1 and 2. So therefore, it cannot contain the number 1. What about number 3? Well, 3 can have a 6 on its side, but that's the only number it can be paired with in a black Kropki, so nothing could go on the other side of the number 3. So it cannot be a number 3, and it cannot be a number 6 for the same reason. What about a number 8? Well, 8 can have a 4 on its side, but now you don't have anything on the other side of the 8. So this also cannot be an 8. And now, because it does not have a 3 or 6, these side cells cannot have a 3 or 6 either. So this looks like this. And same reasoning up here gives you that these and these, none of these can have a 3 or 6, and these central squares must be a 2, 4. So let's quickly fill in everything with every possible value these cells could take. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now this and this are a 2, 4 pair, meaning none of these cells can have a 2 or a 4, which gives you a 1, 8 pair, so none of these cells in this row can be a 1 or an 8. Now, if you take a close look, let's assume that this is a 1. Well, if that's a 1, then this is a 2, and then this is the 4, so you have a 2 and 4 here. And if, however, this was an 8, then this would be a 4 and this would be a 2. So in both cases, 2 and 4 are somewhere here in some configuration, meaning that this is a 2-4 pair. So you cannot have a 1 or a 2, or an 8, sorry. So this is a 2-4 pair. And same is true over here. So if this is a 1, this is a 2, this is a 4. And if this is an 8, then this is a 4. And then this is a 2. So no matter what, 2 and 4 have to be here. So this cannot be a 1 or an 8, giving you a 2-4 pair. And therefore, nowhere else can you have a 2 or a 4 in this in these boxes or columns. 2 and 4. Perfect. Okay, so now you'll notice another fact of the symmetry. It's basically that if you take a close look, everything here on this side and everything here on this side has the same possible values. It's just completely the same. And all the information we have as well, it's the same. So from this information, we cannot possibly conclude something about this value right here, or else we could, again, just flip the Sudoku and conclude the same about this value. So if we are to place a digit somewhere, we could only really place a digit here in one of the central squares, which is equally far away from both sides, thus respecting the symmetry. And that is precisely what we're going to do. So we have a 2-4, 2-4, meaning that nowhere here in between can we have a 2 or a 4. Okay, so now in this box right here, a 2 and the 4 must show up somewhere here. But these three cells form a consecutive group, and a consecutive group that has 2 and 4 in it must contain the number 3 in the middle, and therefore this is the number 3. And now it's surrounded by 2-4, so we cannot have anything else except for 2-4. So that's what I meant by symmetry. Now, finally, you'll see that this reveals some new stuff. Basically, these cells and these cells are consecutive. And if you take a close look, none of these cells can contain the number 1 because the cell next to it would not be consecutive to it. And also, none of the cells can contain the number 3. So if this is a 3, it wouldn't be consecutive to this. And same on the other side. Okay. So now the only place left for the number 1 is again on this line right here in this box number 2. Okay, so that's the number 1. Placing it did reveal some new information. It reveals that these cells are consecutive. Therefore, this cannot be the number 9. So if a number 6 was not here, then that would be a 5, 7, and they would not be consecutive. So a number 6 must be here somewhere. And therefore, number 6 cannot be anywhere else in the same row or box. Okay. Now, what else can we do? Well, it revealed also a black Kropki pair over here, and we know that this cannot be a 5, a 7, or a 9. Furthermore, this is the number 3, so this cannot possibly contain the number 6 either. And now, look at this. Number 4 must be somewhere here in these two cells, because this is either 2, 4, or a 4 something, which also contains the 4, or it is an 8, 4. So in all three cases, number 4 is a part of this somewhere. So if it wasn't, this would be a 2, 8, and obviously that would not respect the black Kropki. So a number 4 must be somewhere there, in which case number 4 cannot be anywhere down here or in this same box, right? So this is the number 2, giving you a 4, 8 pair over here. So you cannot have a 4 or an 8 anywhere in the same box or column. And now, since we have a 2 here, that means that the number 8 cannot be on one of its sides, and that gives you a 1, 4. So nowhere in the same row or box can we have a 1 or 4. Okay, now let's take a look at this next. Basically, this thing cannot be a number 1 because there is no number 2 up here, and vice versa. So none of these can be a number 1. It's completely symmetrical on the left side, so none of these can be a number 1. Furthermore, if this was a 3, then these two would not be consecutive, right? And same on this side. And also this, if this was a 3, then this would be a 6 or an 8. So none of these can contain the number 3. If this was a 6, this would be an 8, so they wouldn't be consecutive. And if this was an 8, this would be a 6, so they wouldn't be consecutive. And it's the same on this side, so neither of this can be a 6 or an 8. And now, since this is a 6, 8, 6, 8, you cannot have a 6 or an 8 anywhere else. And now, this is a black Kropki pair, so this cannot be a 1, and it cannot be a 2, so it's either a 3 or a 4, and same on this side. And that gives you a 3-4 pair. So you cannot have 3 or 4, giving you a 5-7-9 triple. So you cannot have 5, 7, or 9 anywhere in the same row or box. And that finally reveals our next number, which is the number 6. So this is the number 6, and that gives you a 3-8 pair. So this cannot be the 3 or an 8. Now, furthermore, the only place where number 6 can go in the second box is right here. So this is the number 6. What else can we do? Well, we see that these cells are consecutive, right? So none of these cells can possibly contain the number 9 because an 8 is not available, right? And now this cannot possibly contain the number 7 because if it contained the number 7, well, it would need either an 8 or a 6, and neither are available. So this cannot be a 7. Also cannot contain a 5. So this is 1, 2, 3. And now 1, 2, 3, 2, 4, 1, 4. 1, 2, 3, 4. That's a quadruple. And therefore, numbers from 1 to 4 cannot show up anywhere else in the same column. So this and this cannot be a 1, a 2, a 3, or a 4. Meaning that this is the 8, and then this is the 3. Can this be number 1? Well, if one of them was the number 1, the other would be the number 2, right? But then this and this would not be a 1 and 2, making both of them number 4, which is impossible. So therefore, number 1 cannot show up either here or here, because it's completely the same on this side. If this is a 1, then this is a 2, meaning that both of these would be the 4, so number 1 cannot show up here. And therefore, the only place left for the number 1 is over here. So that's the number 1, meaning that this is a 4, and then this is the number 1. Okay, so a number 2 cannot show up over here or the number 3 because now we have a double of 2 and 3. And now that solves some new stuff. This is a 4, and then this is the 2. Now the only place for the number 8 to go in this column is right here. So this is the 8. And therefore this cannot be a 5 or a 6. All right. What else? So 5, 6, 7, 9. 5, 7, 9. Okay, so some new stuff was revealed, mainly down here, but I still don't want to look at it because of this thing. So, how do I explain that? This is consecutive, and this is consecutive. And this has a 2, or this has a 2, meaning that on one of these sides, a number 1 is unavailable. So on one of these sides, you have the 2 free pair. So either this is a 2 free, or this is a 2 free, because in one of these consecutive groups, you must contain the number 2. So therefore, number 3 cannot go here or here. Okay? So number 9 cannot show up here because there is no 8. And now, if this did not contain the number 6, then this would be a 5, 7, which is not consecutive. So therefore, it must contain the number 6, and it can only contain it on this other side. So this is the number 6. Okay? So then that's the 6. I suppose we should finally look at this. I think it's... Wait, this is a 5, 7, 5, 7, meaning that this is the number 9. Okay. So, let's take a look at this. Can this thing possibly be a 9? Well, if this is a 9, there is no 8 over here, so that does not work. Therefore, this cannot be a 9. But if this is a 9, then this is an 8. And now, that means you wouldn't have a 9 or an 8 anywhere down here. So then this would be the 6. So this would be the 3. And now you would not have a 6 or a 3 anywhere. And now that leaves you with a 5, 7 that shows up in 3 squares. Therefore, that cannot be the number 9. Okay. What about number 8 here? Can that be an 8? Well, if that's an 8, then that's a 7. So since this is not an 8 again, that's a 6. So this has to be a 3. So once again, you don't have a 6 or a 3, leaving you with the 5, 9 that shows up in 3 cells, which is a contradiction. So once again, this thing cannot be an 8. And now if this was a 7, it wouldn't have anything down here to be paired with it. And same up here. If this is a 7, this is a 3, 5. So none of these can be a 7. Okay. What else? Well, if this was a 3, then this would have to be a 5. But since this is a 3, then this has to be the 4. And now since these two have to be consecutive, and you can't have a 6 here, then this would have to be the 4. But you've already placed down the 4. So that's a contradiction. So that thing up here cannot be a 3. And it's the same for this. This is a 3, then this is 5, this is a 4, and then this would have to be the 4, but it can't. So this also is not the number 3. Therefore, the number 3 is either here or here, or it's either here or here, meaning that it cannot be anywhere else here. And now if you remember, we have a 2 free pair somewhere, right? We said it's either here or here. So if a 3 isn't here, then a 2 isn't here. And the 2 free pair must be right here. So this is not a 4, 5, 6, 7, 8, or a 9. And now, since that's a 2 free, you cannot have a 2 or a 3 anywhere else in that box. Okay, so a number 3 is either here, here, or here, meaning that it's nowhere here. And that finally reveals some good information. That's a 4, this is an 8, and number 3 is right here. And now this is the number 5. These two are consecutive, so this is the 4, this is a 3, this is a 6. They're consecutive, so this must be the 7. Now 8, 9 cannot be over here, so that's a 6, 7. And let's see, we have a number 3 up here. That's the only square for the number 3 in this box, meaning that this must be the number 3. And now this is the number 3, giving us a number 2 over here. Now, do we have more number 3s? Yes, it's either here or here. All right, so let's just go through the digits very quickly to see if maybe we have some more low-hanging fruit that we can just immediately get rid of. 4, 5, 6, 7, 8, and lastly 9. Looks like we don't. We'll have to keep thinking. Okay, actually these two are consecutive, so this is the 9. Right? Yeah, because this was a 5, the other candidate was 5. 1, 2, 5, 1, 2, 5. 5, 7, 9. These two are consecutive. We still don't know which combination goes there. Now, these cells cannot possibly be containing a 5, a 7, or a 9 because they are a black Kropki pair. And now, this can be a 1, but this can't be a 1 because a number 2 can go here, so this is not a 1. This can be a 4 to be paired with the 8, but this can be the 8. But it can be the 6. Okay. Now, these two are consecutive, meaning that this cannot be a 4 or a 5. And now, if we check the number 4, you'll see that number 4 is here or here, meaning that it cannot be over here. So this is an 8, and this is the 4. Okay? So number 1, number 2, all right, number 3, number 4, where was the 5? That's right here. It's still too messy. Number 6, number 7, eight. Okay, so number 8 is here or here, meaning that it cannot show up anywhere down here. And now since an 8 cannot show up there, then this cannot be a 4 because there is no 2 or an 8. So this cannot be a 4. Okay. So that must mean that this is the number 4. And so this is the 4. So the number 8 must be here. And then here. And then this is 8, 4, 2. This is an 8, 9, 8. These two are consecutive, so this is a 7, 5, 1. I would say that this puzzle is about to unravel completely. So this is a 5, 9, 7. This is a 1, 2, 4. This is a 6, 5, and a 6, 7, 5, 6. 1, 2, 1, 2 is a pair, so this is a 5, 9. A 9 is up here. 7, 6, 5. Then a 5 is here. 9, 7, 2, 1, 2, 1. 1, 7, 2, 3, 6, 1, 9, and lastly 3 and 2. That was a really fun puzzle. I hope you guys enjoyed it, and see you in the next one.